Hello, my dears. I am going over the last 4 questions on last week's quiz because I understand that you all are having trouble. So let's take a look at this real quick. And we're going to look at finding the domain and range of the relation and determine whether or not it's a function. So if we look at the domain, remember the domain is all the x's and the range is the y's, and they've helpfully given us that pro tip because you can see x here and you can see y here. So that's a little help. So we'll go here and we'll look at the x's. And so remember x is back and forth across this way. And so you can see that as you zoom out, you pull it back, right? You pinch it together and pull yourself back there, that this will keep going on forever and ever and ever because it has arrows on the end of it, and that it will keep getting infinitely wide, right? And that's never going to stop getting wide. So we can say that it goes from negative infinity to positive infinity, and therefore D is the correct answer. Now let's talk about range. Range is up and down, right? Range is up and down. It's on the y-axis. Now, the interesting thing about this particular curve is that it doesn't go infinitely down, does it? We see a perfect little stop right here. And if you've got a good enough eye there, you can see that it stops at -1. However, it just keeps going up and up and up and up and up. It never stops going up because look, these arrows on either side keep going up. And so we can say that it starts at -1 and it just keeps on trucking. And so the only thing that might necessarily be a little confusing here, you might be tempted to put the negative infinity to positive infinity, but there is in fact a place where it doesn't go. It doesn't go below that -1. So that's not going to be correct. -1 to +1, well, it does go from -1 to +1, but it keeps going past +1. It's even past +1 on this particular graph. So that can't be correct. What about this -6 to +6? Well, I suppose you might think about -6 down here and +6 up here, and perhaps you might be a little confused. You might be a little confused because it does seem to go up to 6, but remember those arrows say, aha, I know this, it keeps going and going and going. Now, last question, is this relationship a function? And that's where you haul out your writing implement, your pencil, your pen, what have you. You line it up and down on the screen or your desk or your table or whatever, and you put it across each part of here, and voila, it passes the vertical line test. So yes, this is a function. That is how you tell. Now, let's do a really quick refresher on these function, translation, transformation rules. And so if you don't already have these down, let's go over them very quick. So you have your function, add something, it shifts it upwards. So, and that kind of makes sense. You know, if you add something, you have more than you had before because you've added something to it. And so it's going to go higher up than it did. That kind of makes sense. Likewise, taking something away means that it goes down, which again makes sense. If you had something and you took it away, then you have less than. That's a downward kind of thing. And here, this can be a little tricky. When you add B, it shifts it to the left. All right. When you subtract B, it shifts it to the right. And we'll talk about more specifically about why that's true in a moment. But here's something that we talked very extensively about in class, which is that negative function reflects it in the x-axis, up and down. All right, so that it's the inverse over here, so it kind of makes sense with a fraction. Whereas if the negativity happens inside the function, it reflects it in the y-axis, back and forth. All right, so we can think about those in a minute. So let's go ahead and talk about, let's do a sample over here. This was problem number 18 on the quiz. So we use the graph of f of x to graph the function g of x is equal to f of x minus 1. Oh, minus 1. Let's look, minus 1. It's going to shift downward. Downward, okay. So what I'm looking for with that, I'm completely ignoring the things on the right-hand side. I know right off the bat, I'm looking for something that shifts it downward 1. Is there something downward 1? Oh, yes. Yes, there is. So that's our correct answer here. All right, let's try this again. Let's flip back really quick to our rules. We did one of these. What do you suspect the next problem will be one of these? Okay, so remember plus is left and minus is right. And the common temptation is, in fact, to think that f of x plus 3 moves it to the right by 3 because plus 3 is to the right. But the left-right shifting is backward from what you might have expected. Adding moves you to the left, subtracting moves you to the right. And if you lose track, because, life happens, think about the point on the graph where x equals 0. All right, so we have x is equal to 0. If for f of x plus 3, what does x now need for 0 to be plugged into f? In this case, it needs to be negative 3, so that negative 3 plus 3 is equal to 0. So I need to shift to the left 3. All right, so this will tell you where the x value is, and thus the graph has shifted. Um, that might be a little helpful tip for you. You can try it. So if we look at this, we're going to say that we're moving 1, 2, 3. So our line, the middle of our line, should in fact be 3 over. So it's 4 long, and I drew over top of it, and I'm going to move it right here. So this is where our 3 should be, and now I'm going to highlight it with yellow because I find that difficult to see clearly. So here's my yellow. And do I have something over there? Oh, I do. I have B. I have B again as my correct answer. All right, so and remember that one's a little counterintuitive, but you can do it. So let's take a look at f of negative x. All right, so this is an inverse, but you got to stop, take a minute, and think about whether we're inversing over the y-axis or the x-axis. And remember, when it's on the inside like that, we're rotating around the y-axis. Okay, so any points on the y-axis stay on the y-axis. It's the points off the axis that switch sides. This is always true. G of negative x is the mirror image of G of x. All right, so they're mirroring each other. Plugging in the minus of the argument gives you a graph that is the original reflected in the y-axis. So you're like, okay, I'm confused. Remember that you're swapping the x values. Whatever you gotten for the x values on the positive or right-hand side of the graph, you're now getting for the x values on the negative or left-hand side of the graph. Because remember, it's the x we're making negative, not the whole shebang, just the x part. And since the input switched sides, so also does the graph. Well, that's great and that's wonderful, but if this goes here and this goes here and all we had was a line to begin with, does it visibly change to us? Why no. It's like we turned the line 180 degrees and we're not going anywhere. So it's going to be something that was the original here. So hopefully this refresher on function transformations has been helpful. Remember, again, write these down in your math notebook. Think about them, cuddle them, love them, name them George, and remember them forevermore. Good luck.